Right. Thank you. Hi, everybody. I'm Wei Chen. I'm a assistant professor in the School of Engineering and Technology. And today, I will talk about my research on localization, control, and security in public safety network. So basically, I'm going to do my research to support first responders. Okay. And I was told, so this is the first time I do this type of presentation. Once I click this, so I can get my hand off the view. All right. So, so I'm doing actually three things for first responders. So localization. So that's basically I want to tell the first responders where they are in the building, and I also like to people outside to know where are those first responders. For example, in a fire building, which may be a very high building with several levels of basement. So the current localization technique does not work for that. So in the circumstance, like there's a fire there, so there may be no electric, so all the infrastructure may down. So in that circumstance, what we can do to guarantee we can always locate the first responders and we can communicate with them, okay, in real time, okay. So the goal is, okay, objective is to locate first responders, so provide indoor navigation service to help the people to know where is the first responders, how to find them, and then keep the first responders connected, so that they can communicate with each other with the outside, like say, outside station. So keep them connected. So sometimes I talk with, I know the first responder said, okay, walkie-talkie. Sometimes does not work in the building, inside the building. Okay, although they have a long communication range. All right, and also, definitely, so we're targeting on the research object like the service should be available without any infrastructure support, because we cannot assume there's electrical support like that. Okay, and basically, our goal right now in this direction. So the research, those goals are sponsored by NIST. So we have Project NIST for public safety networks. So this is a new research topic actually coming out several years before, and right now it's becoming more and more hot because I think NIST already created a center in Colorado, so for those type of research. And so for our solution, so we build a smartphone-based solution. So we use a peer-to-peer based communication and localization technique. Okay, and we use acoustic for ranging and communication in some cases, and we can support multiple phone simultaneous localizations, and we can provide 1 to 15 centimeter accuracy in the range up to 100 meters. Okay, so basically, in our implemented solution, so this is an app, just a smartphone app, and once the phone can be installed app, so the first responder can use that app to find each other's relative location. Okay, and the app can also tell the first responders how to reach destination. Okay, the destination could be other responders, first responders, can also be other, like say, person who need help. Okay, and then the first responder can also use the app for the communication. So this is just a demo of the app. So in this demo, we have 3 smartphones app. So but we have 6 first responders. So in the app, we see so each responder has their own symbol, and they will see their relative location. Okay, and they can find a way how to find each other. Okay. So this is just a first prototype we built. So right now, we are adding more function to that, including communication. And as I mentioned before, we also add simultaneous multi-pair localization. That will significantly reduce the localization time. So right now, our localization time for those, like for example, 6 first responders, so can be limited to within 1 minute. Okay. So which is, I think, is a great improvement. All right, so next we'll talk about control and security. So for the first responders, when they got into the situation like a building in fire, we want the first responders' hand be hand-free. Okay, so they need their hands for some other jobs. Okay, for example, lifting some heavy things. Okay, find people. So our goal is okay. So we know we keep adding more devices, more equipment for the first responders to carry. Okay, so they have some devices for communication, some devices for control, some controllers who measure the distance or so something like that. So we want to give first responders options like a hand-free control. Okay, and then the other thing is we want to minimize the equipment size and weight so that we can reduce the load on the first responder. And So we want responders to wirelessly control multiple devices, so without using their hands. And we can also monitor the first response status. For example, we want to know whether the first responder is operating normally or is in some situation which is bad situation, for example, for the health. And we can also provide security for control and communication. So security for the first responders is also important because in the situations we do not want any other attackers or other malwares to intercept the communications between the first responder and the outside command center, or for intercept the communications between the first responder with the device controlled by the IFRs. Okay, so that's another concern that we are working on right now. And so our goal to do that is we can use a simple device. So this device is just as simple as a band. Okay, so we just need to attach that band to the skin of the first responder. So we can ask these small sensors actually to detect the signals from the muscle movement or skin changes, okay, on the first responders, and so that we can get all those information. So that is the picture of the sensor we're using right now. You can see the sensor is quite like a tattoo. Okay, we just apply that tattoo to the first responder skin, and from that sensor, so this is a nano EMG sensor. It can measure the muscle movement, it can measure any movement on the skin. Okay, and then we use that signal for the purpose of control and security. And the technique we use, including the machine learning techniques, the signal processing techniques. So to do that, we can know. So for example, if we attach that sensor on the skin like here, okay. So when the first responder moved one finger, okay, or maybe just squeeze. So we know, okay, this means okay, I want to talk, or this means I want to open something, I want to close something like that to control the devices. Okay, and we can also use those devices, those signals for the purpose of security. For example, we can use that for this initial pairing. Okay, so for example, at the time we send first responder to a fireplace, so first responder can attach this one and make some movement like this, and then this movement actually will help the first responder to pair with each other. So basically, we use this series of actions, okay, as a parse code. Okay, so that first responders, their communication, they are protected, and the communication between the first responder and their controlled device are protected as well. So overall, the overall impact, I think, is that we provide the real-time location services to the first responders, and we provide wayfinding services, and we can monitor the status of first responder, and we provide hand-free control and security protection for the communication. Okay, all right, thank you.